Hi everyone, my name is Bhavishya. In today's lecture, we'll learn about IP version for header. Before jumping into it, let us understand the PDUs. Let us revise the PDUs. In the layer 2, the PDU is called as frame. Okay, so what was it there? What was in there? We had our L2 header, layer 2 header. We have L2 trailer. Okay, trailer. After that we have our packet. So this was when it was called as frame. If we come above, then in the layer 3 we had our segment plus our L3 header. Okay, and this L3 header is known as our IP header. So we'll learn more in detail in this video. After that, in layer 4 we have our segment. It is known as segment. So we have data and our L4 header where we decide UDP or TCP IP, right? So let's jump into IP header. So IP header is necessary for a router to decide where to forward the data to its final destination. So the very first thing we have in our IP header is version. So in version we have two types. We can select IP version 4 or we can select IP version 6. If it's the IP version 4, the value would be 0, what exactly it was, 0100, I guess. Yes, if it is version 6, then it is 0110. I may be wrong, but yeah, this is what I remember. After that we have our IHL, which is internet header length. It decides the length, it decides the total length of the header. After that we have DSPC, or you can say quality of service. So this is where it decides which particular, let's suppose we have voice or video. So we will prioritize this more in all of the data. We'll prioritize this. So this decides the priority of any data in the datagram. Okay, after that we have identification, we have flags, we have fragmentation, offset. This all comes under the fragmentation part. So fragmentation is when we have a set of data. Let's suppose we have a data, we fragment it down to, let's suppose, 3 paths, and then we'll send it. We don't really send the whole data, we fragment it and then we send it in parts. So this is called fragmentation, right? So in fragmentation, the very first is identification, where we resembles the fragmentation packet. Okay, after that we have flags. So in flags, it controls and identifies the fragmentation. Okay, after that in fragmentation offset, it indicates the position of fragment. It identifies the position of fragment within the original what we say, unfragment packet, in the unfragment packet. After that we have TTL, time to live. Time to live is basically, it is used for it is used so that it doesn't goes into the infinite loop in the network. So the value, the default value that we set is, it is set as 64. It will come down to 0. As it reaches to 0, the datagram will be dropped, and this is when we'll see the ICMP message, as we have learned in the previous one. After that we have our header checksum. This is where it checks for the error. So as we have learned in the previous ones, that in our layer 2 we have header, tailor and packet. So in the tailor part we have this dedicated FCS for the error checking, but here in this case, in the IP header, in the IP version for header, we have in this particular field as header checksum to check for the error in the data. After that we have our usual source IP, where we have the version for IP address of the sender. Then we have destination IP. Then we have the destination IP intended IP of our receiver. Then at last we have optional fields. So this was the brief about our IP version 4 header. I hope you liked and enjoyed. See you in the next one.